All right, here we go. We have the same region R is the base of a solid, and we've been told that if we slice it perpendicular to the x-axis, that slice is going to have a shape whose face is a square. So the face is a square, but it's a square with thickness, like a Kraft single. So can I write an expression for the volume of this solid? Well, since I took my slices perpendicular to the x-axis, the thickness of each slice is a very small change in x. So I'm going to integrate with respect to x, which means I need x limits on my integral. The furthest left x in this picture is 0, and in the last video we decided the furthest right x is 2. And what do I need here? If I want my final answer to represent a volume, it means I have to add up infinitely many volumes. So volume, the volume of a cheese slice is going to be the area of the square face times the thickness. Well, here's the thickness. So now I need an expression for the area of the square face. Well, how do I find the area of a square? I take the side of the square and I multiply it by itself. So what I need is an expression for the length of the square. And I could tell that if I drew in all those cheese slices for this whole cheese shape, that every one of those vertical line segments I drew, which represents where my cheese slice hits region R, the top hit this curve, which I know is y equals 4, and the bottom hit that other curve, whose equation I don't remember off the top of my head, x to the fourth minus 2x cubed, I think. So I'm going to write an expression for the side of the square. That's going to be 4, the top y, minus this other guy, which was x to the fourth minus 2x cubed plus 4. So now, what do I need here? I need an expression for the area of that square, and that's going to be 4 minus x to the fourth minus 2x cubed plus 4, all squared. Squared because I find the area of a square by finding one side and squaring it. Dx, because that's the thickness of every slice. 0 to 2 because of the x limits on my x integral. Final answer. Okay, this time I've been told, same idea, I have R, it's the base of a solid, but this time when I slice, I get a half of a cheese slice cut along the diagonal. So an isosceles right triangle. Let's draw that in. So when I slice, my slice has a face that's a triangle, and the two legs, the two sides that contain the right angle, one of them is across my region R. So how do I find the area of an isosceles right triangle? Let's get that up there. Well, let's see, isosceles right triangle. A couple ways to think about it. Area of a right triangle is 1/2 the base times the height, but the base and the height are the two legs, meaning the two sides that aren't the hypotenuse. And in this case, those two legs are the same because it's an isosceles right triangle. So the area for an isosceles right triangle, 1/2 side squared. So turns out, another way to think about it, that's just my cheese slice from the last problem cut diagonally. So it has an area that's 1/2 of the cheese slice from the last problem. So I'm going to have an integral from 0 to 2, 1/2 side squared dx. And this is the same side because I have that same region. So 4 minus, x to the fourth minus 2x cubed plus 4. So this integral is going to look exactly like the last integral except with a 1/2 multiplier in there. All right, here I'm going to answer question 25, but I'm going to scroll back up here so I can see this picture. The vertical line x equals k divides, oh, this should say region R, into two sections of equal area, right? But do not solve an equation with at least one integral expression whose solution would be k. All right, so I'm going to sketch in a vertical line, x equals k. And I want to write a statement that's true, and my statement somewhere in it has to include k so that I could solve it. Not that I'll know how to solve it, but it could be solved by someone to figure out what k is. So I could write, so I'm going to say some things that are true, and then we'll talk about translating them into English, from English into math. So I could say that the area of R to the left of k has to be equal to the area of R that comes to the right of k. Or I could say that the area of R between 0 and k, so the area in between those two curves that I've always had between 0 and k has to equal 1/2 of the total area of R. Those are both good ways to go. Just because it might be easier to understand, I'm going to write this integral, but don't feel like I have to do this. I'm going to say the area to the left of k, so that's the integral from 0 to k, has to equal the integral from k to 2. So if I choose k correctly, then half of the area is going to be to the left of k, and half of the area is going to be the right of k. And both of these I'm going to integrate with respect to x. And in both cases, the area I'm talking about is the same area I've been talking about the whole time, which is 4 minus x to the 4th minus 2x cubed plus 4. Technically, that should get a pair of brackets so that the dx applies to all of it. They would never mark you down for that on the AP test, though. One possible final answer, not the only final answer, not the only possible integral equation you could write, but this one is definitely correct.